My name is Vasile Crăciunescu. I'm from Romania, from Bucharest, from the National Meteorological Administration, Remote Sensing and GIS Department. I'm also leading the OSGeo Romania group, and I'm always scared in presenting in FLOSS4G because this is the meeting of tribes, and you have a lot of developers, and I'm not a developer, and I'm always afraid that people will expect to see things like coding and so on. And I had this experience in 2009 in Sydney to replace Skylar Earl in this very popular guy, and I was totally everyone expected different things. So today I would like to talk about this project we are doing in a Met office. It's a European project on an important topic in Romania, in Europe, and worldwide: the water quality. Because as you may all know, we do have a lot of issues with water quality, and the future does not look good. But first, what CLEANWATER stands for. So it's the name. This is the acronym of the project, but the real name means Integrated System for Protect and Analyze the Status and Trends of Water Threatened by Nitrogen Pollution. The project doesn't focus only on nitrogen, but on more other issues on water quality. And it's financed by the European Commission through a framework called LIFE program, and a financial instrument supporting environmental and nature conservation projects. It aims to develop at a basin scale, so it's quite like not a pilot, but it's for just one major basin in Romania. So it would try to create an integrated management system to see when the water quality is threatened, and to be able to enable the decision makers to try to simulate what will happen in the future, and to take the right decision. So modeling, and then assess and analyze the results. And of course, because the subject of the project has a very big geospatial component, and we did all this component with free and open source software, and that's the reason I'm here to present it to FLOSS4G. Beside the Met office, we also have some other partners in the project, mostly related with water. So the National Institute for Hydrology and Water Management, Romanian Waters, and so on. Have to speak about our end users, because there are national and local authorities, and their job is to make sure the water quality is good. Are in charge and responsible on the good quality state, and to be able to assure this water complies with the national and European laws. And there are quite a lot of directives in Europe that deal with water quality. It's quite an important point. And these decision makers, they need instrument to understand the impact of the new industrial or agriculture investment in their water basins. And they do not possess any knowledge whatsoever of how to run a numerical model, a mathematical model, to simulate the water quality, and they don't know how to use GIS software. We are from different business. They simply don't know how to deal with this kind of technologies. They do know how to use simple tools like Google Earth, Google Maps, and this kind of easy mapping frameworks. And of course, we are looking for nice tools to be able to create scenarios that involve future water quality improvement. So they need to take decision to improve the water quality, but they need a tool to simulate what will be the impact of those measures. And also, it's not only the impact, but what's the cost of that measure. So that is why we have to somehow bridge the part of the numerical modeling, in situ data collection, with some nice, easy-to-use interfaces. Of course, geospatial-enabled interfaces. And we did this through an online GIS system. Distributed with the distributed architecture that could be run by anyone in the browser. So we could do data visualization, query, and spatial analysis. Simple one, not very complicated one. We could create new scenarios, so that involve water quality, and send those scenarios to a numerical model. So we are able to through easy-to-use interface to modify the inputs in the model, send it to the models, and then receive the results and have some tools to analyze and see what's the outcome of was a measure in after the modeling. And of course, because you see everything rotates around the money, because if you have plenty of money, you could, I don't know, take all the measures necessary to have a good quality state of water. We have to somehow prioritize. Of course, it could good to use the money in the best way. So you need to have like analysis of cost effective of the measure you're proposing, and to integrate with some popular mapping platforms. So I'll not talk about numerical modeling. It's not my area of competence, but for this project we are using three types of numerical models. First is for the surface water quality in this model developed by the Pierre Marie Curie University in Paris, France. It's called Senec River Strahler. We use ModFlow and for the ground modeling, for the groundwater quality modeling, and there are some in-house developed models to model some soil parameters needed for this. And I'm also here in this conference because this project has some previous, was built on a previous experience, a project called Diminish, and it's a good thing that this project is also an example of migrating from proprietary solutions to free and open source one, because the previous system, more rudimentary, was built entirely on things like ESRI, ArcIMS, and we use Microsoft Stack and for the databases and for programming language and so on. And then this happened in 2005, 2006, and in 2006 I attended FOSS4G in Lausanne, and I was amazed by what the free and open source technology can do. And I simply for the new project I removed everything we had, and that was some example of the previous project, and went for the free and open source solutions. So the project started with some system requirements. Being in this quite complex context, we had to take in account a few initiatives and standards, like the INSPIRE directive, which is very important and in Europe. And also we have some satellite data, and we somehow have to take into consideration GMES, or the actual Copernicus, the European program for space observation. SAIS, that is a European Shared Environment System. We'd like to think that what we are building now is an example of SAIS, and some directives, and the most important is the Water Framework Directive in Europe. And that's some technical stuff. We got these requirements from the end user and taking account the mentioned initiatives, and we end up with things like general requirements, data requirements, functionality, security, hardware, software. I'll not bother you with this because it's just what the system should do. It's like, yeah, we need interfaces for WMS, for WFS, for all kind of things, performance things, and we got like a big document with what the user needs, and then we had to assemble a GIS database, and of course we got what was already on the available in different institutions, but we had to work a lot, almost 1.5 years. We did a number of field campaigns, and it took I don't know if 1,000, but many hundreds of field measurements regarding water quality and other issues, and it was quite time consuming, and we spent quite a lot of time to try to make this GIS database compliant with what the Water Framework Directive was saying, and the INSPIRE Directive. It should sound easy, but it's not. Trust me. And this is the content. I will not get into details. We also have like a data fusion application, because we were still receiving data from a number of institutions across the country, and they all use different file formats, different platforms, and we have to somehow to create a layer that could translate the data we're receiving in some standard formats to be able for our system to use. And of course we make use, beside open software, we do make use of open standards. And for this project, we are using standards, of course, issued by OGC, ISO, and also the standards from Inspire, but we are the similar ones. So one of the most important are the portrayal, data portrayal standards like WMS and WMTS. So this is the main vehicle of transporting the data from the GIS server to the clients, the web and desktop clients. And we also like our users to be able to download their data and use it in their own environments. So we set up also some download services for the vector based on WFS and for the raster data based on WCS. We have a catalog. We don't have as much data as you may think, but at some point it's very good to have a catalog that is also use some standards for the search to be able to be harvested by third-party catalogs, and we created metadata using some well-known standards. And we also use some light formats like GeoJSON and KML to stream the data. So we use GeoJSON inside our web application. We give the users the opportunity to take the data out as KML because everyone knows how to use Google Earth. So now I'm talking only about the geospatial system architecture, which is, as mentioned, a distributed one. We have a database management service, a catalog service, a data delivery and portrayal service, and one software client. And the general things look like this. So we have the user somewhere could access the system through a web client. Is how we think most the project. But if they have greater knowledge and they prefer to use their own tools, they could use a desktop client. So they could connect to our system and make all kind of requests. Behind we have the database, the catalog, and the services, and we stream back the responses to them in different type of formats like maps, raw data, services, charts, animation, and so on. And we also have the project partners who are feeding also the system with numerical model simulations and the economic analysis, which is quite complicated, and I could not really understand it, but it has to go there somehow. And if you zoom a little bit on the technology, because we are in the FLOSS4G conference, this is the tools you are using. So for the client, you are using JavaScript libraries like ExtJS, GeoExt, OpenLayers, and a number of other for float, for charts, and so on. And we are testing the system with things like QGIS, UDIG, but also ArcGIS, because some of our end users have ArcGIS or Google Earth. And then on the server side, we have like a normal stack with Apache, Tomcat, Java, PHP, and Python for server-side processing, and then we store all our vector data in a Postgres plus PostGIS database. For the raster, we are still using a normal plain file like GeoTIFF, compressed GeoTIFF files. Use GeoNetwork open source for our catalog, and it's a nice product to integrate quite well with other Inspire related catalogs across Europe. And for our GIS server, so to be able to deliver data as WMS, WFS, and so on, we are using GeoServer and the GeoWeb web cache. And as I said, the user can get back a number of the results in a number of ways. Now, for the final part of my presentation, I'll present a little bit of facts about the web client, because that's the public face of our system. So it has just a very simple interface. I could say it's very rudimentary. It's not supposed to be very fancy. It has to be effective. So this has two parts. One is for scenario management, so a place where the user can create scenarios, choose what input data they want to use for the scenario, and so on. And then we have the normal web mapping application based on OpenLayers and GeoX with a main map, some layers they could switch on and off, and adjust transparency, and a number of tools, and they could use to query the database there. They could mix different information there. They could edit, and we spent quite a lot of time for maybe not such a useful thing. They could create their own layers, or they could edit some of the existing layers. So, for example, to create a scenario, it involves to edit the, for example, the industrial. The industry in the area, so factories, power plants, and so on. So you could delete or add new this kind of objectives that are very important, because they all affect the water quality, and they also could change a lot of parameters. So it's not only geometries but the attributes. So because you'll need to know how much, I don't know, the wastewater, how much they are bad water they are sending out, and you also have things here like the I don't know the name, the station we are cleaning the water. So again, with a lot of parameters and stuff, and that's why you're required to do a lot of editings and so on. And you could use a number. We also deploy some WPS services. So for especially for vector data, the most simple example is to create buffers. So you could select existing elements, or you could create your own. I don't know what, could be vulnerable areas or whatever, sources for pollution and whatever. And you could do things like buffering and others. And then you could create complex selections using also this kind of buffers and the attributes and so on. And of course, you could view and analyze the outputs from the models. So this is an example of the groundwater model. What you could do a lot of thematic maps with the outputs of the models, just to understand what is there. And we have a chart module you could do. So there's like you could create charts for hundreds of cross sections, and on the where a basin is closing, per basin, and so on. You could animate the charts to go in time for 1 year, for 1 month, for more than that, to go along the river and so on. So most of these guys seems to look a lot of charts, and yeah, understand the impact of the measures they are taking. You could put charts also on the map and so on. You could see it in Google Earth. Yeah. So for the future work, because the project I didn't mention, but is just past this half time of the project. So we are not done. We have a lot of work to do still. So we have to finalize the integration of the models and the environmental cost, because there are some issues there. And we would like to improve the visual look of the system. We want to put our own custom ExtJS theme. We want to use Bootstrap for all the parts with forms and where the scenarios are created and so on, because they look very pretty. They scale on different devices. You could use it on tablets and so on. Bootstrap is a great technology. We have quite a complicated document for system validation. A number of components has to be validated through using some standard steps. Have to do user training, and we want to open the data. I'm a big fan of open data, and we collect quite a lot of data, and there's not so much data open at this point in in Romania at least, and the water quality is an important issue, and I think that everyone should be able to access this kind of data and understand how good or bad the water quality is in his area, and yeah, this should be important. And with this geospatial stack, we want to go live no longer than January 2014, and of course have more fun in doing things. So this is the end. Thank you. If you have questions, please ask me. We are a little bit behind the time, but that's not my fault.
We have enough time.
Okay.
We have roughly 5 minutes or so, so we have enough time for questions. Thank you very much, Vasil.